This is a linear inequality two-variable homework solution demonstration, I guess. Okay, we're trying to graph a linear inequality. Y is greater than x. Strictly greater than. Remember, we have to graph the equality first. Y equals x. Now, when we graph this equality, we're going to need some graph paper. Here we go. And if we notice, in slope-intercept form, starting from our first principles here for this first problem, we have a slope of 1, our m value, and a y-intercept is 0. So if we remember, what this means is I start by plotting my y-intercept at the origin here at 0. I'm now going to use the slope. Now my slope here is 1. But if I write this as a fraction, I divide by 1. So I have a rise of 1, rise, and I have a run of 1. So in order to determine the next point here, I'm going to go up 1 and to the right 1. This is the location of my second point. Now, I'm going to use a highlighter here to illustrate what we're talking about. These two locations are what I'm going to draw my line through. And this line is going to be dotted. The reason it's dotted is because we have the strictly greater than sign. So when I actually draw the line here, we're going to have to draw it through these 2 points. Here's my dotted line. Now I need a test point because this line separates my graph into 2 regions, an upper left and a lower right. So I need a test point that's clearly not on a line. So let's pick the point. X is 1, 2, 3. Let's pick the point 3, 0. Now I'll illustrate this. This is where x is 3, and this is where y is 0. So if x is going to be 3 now, and y is going to be 0, I'm going to plug 3 in for x, plug 0 in for y. Notice I get 0 is greater than 3. This statement is false. So what this means is we don't shade the lower right region, we shade the upper left region. Every point in the upper left region will give us a true statement. This is why we shade it. Notice if I choose the value for x now in this region, maybe choose x is going to be 0, y is 1, 2, maybe 3 right here. X is 0, y is 3. Plug in 0 for x, plug in 3 for y now. We get 3 is greater than 0. This here is a true statement. And this is why we shade the upper left region. We're done. Number 3, y less than or equal to x plus 1. Again, we start off by graphing the equality. Y is x plus 1. Now notice a few things here. This here is less than or equal, so we're going to have to graph a solid line this time and not a dotted line because of the condition of equality. And again, we're going to look at the details of our equation. My slope here is 1. My y-intercept is 1. So I'm going to use a slope value of 1, write it as a fraction, 1 over 1, and my y-intercept being 1. We're going to graph this. plotting where 1 would be on the y-axis is right here, the red dot. Using the slope of 1 means I rise 1 and I go to the right 1. So here's my 2 points. I'll emphasize the 2 points. Y-intercept at 0, 1. I rise 1 and I run 1. Let's draw our solid line. And we draw our solid line through these 2 points. What we're going to do now is determine a test point, and it's going to be a point that's not on the line. It's going to be in either the upper left region or the lower right region. I noticed that the origin is available. It's not on the line. So let's kind of emphasize where that is. The origin here is 0, 0. If I really emphasize it, that's the location, 0, 0. It's not on the line. That means x is 0, and it means y is 0. I'm going to verify this inequality. 0 less than or equal to 0 plus 1, which is 0 less than or equal to 1. This is a true statement. What that means is I'll shade the lower left region because this is the region in which our test point lives. Every point in this region will satisfy the inequality. This is our graph. Number 5. Y is greater than 2x plus 1. Notice this is a strict inequality. We're going to have a dotted line. We first start by graphing the equality, which is y equals 2x plus 1. Let's notice my slope here is 2 and my y-intercept is 1. So I have m is 2 over 1 and my b is 1. We need a graph we first start by plotting the y-intercept. It's on the y-axis at 1. There we go. We're going to use a slope of 2. Now, the rise is 2 and the run is 1, so we go up 1, 2, and run 1 from our y-intercept. Y-intercept here is at 0, 1. This is the location of our second point. We can emphasize that here. Let's draw our line. And again, since it's a strict inequality, this line has to be dotted. We need a test point. Hopefully, the origin is available. And if I look closely, it is. The value x is 0 and y is 0 is available. So I'm going to plug those values in. X is 0, y is 0. Into my inequality, I get 0 greater than 2 times 0 plus 1, 0 greater than 0 plus 1, 0 greater than 1. This here is a false statement. That's false. That means we shade the opposite region. We shade the upper left region. Every point in this region will give us a true statement. We are done. Number 7. Y is greater than negative x plus 1. We start by graphing the equality. Y equals negative x plus 1. Notice this is a greater than or equal inequality. Involves a condition of equality, greater than or equal. We're going to need to use a solid line this time. We first start by graphing m and b. M is negative 1 over 1, and b is 1. We need a graph. We're going to start first by plotting our y-intercept, and our y-intercept again is at positive 1 right here. This is our y-intercept. We're going to use now the slope. This time the numerator, the value of m, is negative 1 over 1. That numerator is negative. That means we go down 1 and then to the right 1. So the location of our second point is right here. Down 1 to the right 1 from our y-intercept value. We're going to draw our line. This time, we have a solid line, so our line should look like this. We need a test point that's clearly off the line. So I might use x is 1, 2, y is 2, a point out here. Let's double check. X is 2, y is 2. X is 2, y is 2. The inequality becomes the following. We're going to need some space. X is 2, y is 2. Notice what this becomes. 2 greater than or equal to negative 1 times 2 plus 1. If I do my arithmetic on the right-hand side, I get negative 2 plus 1, or I get the statement that 2 is greater than or equal to negative 1. This is a true statement. What this means is we shade the upper right region. Every point in this region will give us a true statement. Let's be a little neater. Make sure it's in the region. We are done. Number 9. Y is greater than 2/3 x minus 2. This is a strict inequality, so that means we actually use a dotted line. But let's start by graphing y equals 2/3 x minus 2. My m value, my slope is 2/3. My y-intercept is negative 2. Slope is 2/3. Y-intercept, negative 2. Let's graph. We're going to start by plotting the y-intercept at negative 2. So it's on the y-axis at negative 2. Okay. Notice x-axis, y-axis. Negative 2 is clearly down here. We're now going to use our slope. Our slope is 2/3. We go up 1, 2, to the right, 1, 2, 3. This is the location of our next point on the line. We're going to draw our curve. Draw the line. Notice the origin is available. The origin is available as a test point, 0, 0. So I'm going to use 0 for x and 0 for y. We're going to test this inequality. We're going to need some space. Zero is greater than 2/3 times 0 minus 2. Anything times 0 is 0. So we're saying that 0 is greater than negative 2. This is a true statement. We're going to shade the upper left region. And you're done. Number 11. 2x plus y is greater than or equal to negative 6. Notice we have a greater than or equal. We're going to ultimately use a solid line. But in order to first graph this, we have to graph the equality. We're going to have to solve for y to get this in slope-intercept form. So we're going to need to subtract 2x from both sides. We end up with y equals negative 2x minus 6. Now here, if we take a closer look, our m value is negative 2, our b value is negative 6. So my slope here is negative 2 over 1, and my y-intercept is negative 6. I'm going to have to graph this. Notice, here's my x-axis, here's my y-axis. I'm going to graph negative 6 on the y-axis. That's down 6. 1, 2, 3, 4, 5, 6. Right here. I'm going to use highlight the location of where negative 6 is on the y-axis. We're going to use a slope of negative 2 over 1, which means we have to go down 2 and then to the right 1. From this intercept, 1, 2, to the right 1. This is the location of my next point, highlighted. It's down 2 to the right 1 because my slope is negative 2 over 1. Let's draw our line. Our line again is going to be solid because it's a greater than or equal to sign for our inequality. Good enough. Not so simple to do, nevertheless. The origin is available as a test point. That's x is 0 and y is 0. We're going to have to test this inequality. We're going to need some space. Now 2 times 0 here plus 0 has to be greater than or equal to negative 6. 0 is greater than or equal to negative 6. This is a true statement. We need to shade our region. We're done. Number 13. 2x plus 3y is greater than or equal to negative 9. This is a greater than or equal to sign, and what that means then is we have a solid line. However, we're going to have to solve for y, because what we're going to have to do is graph the equality, which is 2x plus 3y equals negative 9. Solving for y, we subtract 2x from both sides. We end up with 3y equal to negative 2x minus 9. We're now going to divide both sides by 3 to get cancellation. We end up with y equals, now this 3 is dividing both terms, so it's going to be negative 2/3 x minus 9/3, or simply y equals negative 2/3 x minus 3. This is in slope-intercept form. My m value and my b value. My slope is negative 2/3, and my y-intercept is negative 3. We're going to have to graph this. Slope is negative 2/3. Y-intercept is negative 3. Slope, negative 2/3. Y-intercept, negative 3. Plot where negative 3 would be 1, 2, 3. This is my x-axis. This is my y-axis. Negative 3 is below on the y-axis. 1, 2, 3, right here. I'm now going to use my slope of a negative 2/3. Now, keep the negative sign on top for your negative slope. What that means is I go down 1, 2, and to the right, 1, 2, 3 from that y-intercept. I'll highlight my points because I'm going to have to draw my graph. Now this is a strict, or I should say this is greater than or equal, which means we're going to have a solid line. Let's draw our solid line here. Here's our solid line. Through the 2 points. Notice again our test point of 0, 0, or the origin, x is 0, y is 0, is still available. So that's x is 0 and y is 0. Let's go back. We're going to need some space here. Go back to the original inequality and use your test point of x is 0, y is 0. X is 0 and y is 0. You get 2 times 0 plus 3 times 0 is greater than or equal to negative 9. and I get 0 plus 0 is greater than or equal to negative 9, or simply 0 is greater than or equal to negative 9, this here is a true statement. 0 is greater than or equal to negative 9. That means we shade the region that includes our test point, the origin. This is the graph. Number 15. X minus y is greater than 4. This is a strict inequality, so we're going to use a dotted line. But before we do so, we have to graph the line. We have to put this in y equals mx plus b, or slope-intercept form. We're going to have to solve for y. I'm going to subtract my x from both sides. We end up with negative y equals negative x plus 4. Now, there's a negative 1 times this y, so I'm going to divide both sides by negative 1. We're going to end up with y equals a negative x divided by a negative 1 plus 4 divided by negative 1, or simply y equals x minus 4. So now my slope is 1 and my y-intercept is negative 4. Slope 1 over 1, y-intercept negative 4. Let's rewrite this. We need a graph. Negative 4 for y-intercept is on the y-axis. So negative 4 is going to be down 4 units. 1, 2, 3, 4, right here. Our slope is 1. So we're going to go up 1 and to the right 1 for the next point. I'm going to emphasize my y-intercept at negative 4 and my next point by going up 1 and to the right 1 from that y-intercept. We're now going to graph. Now again, this is a dotted line because we have a strict inequality. If you noticed, your origin is available. That is, x is 0, y is 0. Now we're going to have to go back to your original inequality here. Okay? Go back to the original inequality. Original inequality is x minus y is greater than 4. So if I plug in x is 0 and y is 0, we get 0 minus 0 is greater than 4. Or 0 is greater than 4. This is a false statement. What this means is we shade the region that does not include the test point. We shade the region that does not include our test point. That's the lower right region. This is our graph. Number 17. X minus 2y is less than negative 4. A strict inequality will give us a dotted line. In order to start, we have to first graph the equality. We have to put this in slope-intercept form. We're going to subtract x from both sides. We end up with negative 2x minus 4. We divide both sides by your negative 2. We're going to end up with y equals negative x divided by negative 2 minus 4 divided by negative 2. Now, if I do my division with negative 2, I end up with y equals a negative divided by a negative is a positive. That's positive 1/2. And again, a negative divided by a negative is also, again, a positive. So that my slope here is 1/2 and my y-intercept is 2. So m is 1/2 and your b is 2. Let's graph. My y-intercept, okay, let's label these. X-axis, y-axis, my y-intercept will be at 2, which is above. It's 2 units. 1, 2. This is the location of my y-intercept. Let's notate it. Here we are. We're now going to move up 1 and to the right 2. This is the location of my second point by using the slope. Up 1 to the right 2. We're now ready to draw our line. Now remember, this is a strict inequality, so dotted line. Let's double check. Yes, strict inequality. Notice the origin is available, 0, 0. So go back to the original inequality for number 17, x minus 2y is less than negative 4. The origin is available, means x is 0, y is 0, or 0 minus 2 times 0 less than negative 4. 0 minus 0 less than negative 4. We get 0 less than negative 4. This is a false statement. That means we shade the region that does not include the test point, the upper left region. You are done. Number 19. (3x minus 2y greater than or equal to negative 4). This is greater than or equal, so we're going to have a solid line. We first have to know what line we're talking about. 3x minus 2y equals negative 4. We're going to have to graph this. In order to graph, we have to solve for y and place this in slope-intercept form. Negative 2y is negative 3x minus my 4. Divide both sides now by negative 2. We end up with y equals negative 3x divided by negative 2 minus 4 divided by negative 2, or y equals 3/2 x plus 2. Notice this. We have a slope, a y-intercept. My slope is 3/2 My y-intercept is what? 2. Slope, 3/2. My y-intercept, 2. Let's graph. Notice again, here's our x-axis, our y-axis. We're going to start by plotting the y-intercept of positive 2, which is above 2 units. Here's the location. We're going to use our slope of 3/2, meaning we're going to go up 3. 1, 2, 3, and then to the right, 2. This is the location of our second point. Up 3, to the right 2. Rise 3, and run 2. Let's draw our line. We have to draw this line through both of these points. Again, this is a solid line because we have greater than or equal. Luckily, our favorite test point, the origin, which is x is 0, y is 0, is available. We're going to now have to verify for question 19. (3x minus 2y is greater than or equal to -4. We plug in 0. We plug in 0. The nice thing about this origin being available is that I get essentially 0 on the left. My arithmetic is very easy. Now, 0 is greater than or equal to -4. This is a true statement. I get to shade the region that includes my test point, which is 0, 0 here. It's the lower right region, and it's a solid line. We are done. Number 21. 21. X is greater than 2. Again, we first start by graphing the line x is 2, and notice this is a strict inequality, so it's going to be a dotted line. We need to graph. Okay, we have the x-axis and the y-axis. So the graph of x equals 2, what we do is we notate where the value of x is 2 on the x-axis. 1, 2. The location is right here. X is 2. Now, because there's no y coordinate value, y is arbitrary, but x is constantly 2. What that means is we have a vertical line through the x coordinate value of 2. It's dotted because we have a strict inequality. 23. X is less than or equal to -5. We have, in this case, a solid line because that's less than or equal. But again, we first start by graphing the equality. Again, x-axis, y-axis. This time, our line goes through the x coordinate value of -5. -5 is to the left. 1, 2, 3, 4, and 5. If we highlight this, it's right here. We have a solid line through x equals -5. We are done. y greater than 3. This here is a strict inequality, so we're going to use a dotted line. We're going to start by graphing y equals 3. Y equals 3. If we notice, again, we have our x-axis, we have our y-axis. Y equals 3, if you notice this equation does not involve the coordinate value of x. X is arbitrary, but what we know is we go through the value of y for any value of x. Y is 3 is right here. If we highlight it, this is where y is 3. We get to now draw a horizontal line. Since we could use any x value, or y value has to always be 3, it's constantly 3. This is a dotted line because we have a strict inequality. We are done. Now, I want to go back and say a few things. What we didn't do here is we didn't shade. So at 21, let's go back here and let's shade. We forgot to shade. Alrighty. Now, in order to shade here, let's find a test point that's not on the line. My origin is available again, and what that means is my x coordinate value is 0, and my y coordinate value is 0. If I go back now and I plug in 0 for the x because there is no y coordinate value, I get 0 is greater than 2. This is a false statement. So we have to shade the region that does not include the test point. This dotted line separates my region here, or the Cartesian coordinate, into two different regions, one to the left and one to the right. So what this false statement really says is shade the right region because that's the region that does not include the what? Test point. So here's number 21. This is what you should see. And then similarly, we have a origin available again, and that is x is 0, y is 0. If I plug in 0 here for x because there is no y coordinate, 0 is less than or equal to -5. This here is a false statement. So again, we're going to shade the region that does not include that test point. That's the region to the left. I apologize. Incomplete. These now are the graphs of these inequalities. And once you get to 25, the same idea holds. The test point is available, which means x is 0, y is 0. This is the location of my test point. It's the origin. This time, I plug in 0 for y because there is no x coordinate. And 0 is greater than 3. We have to test whether this is a true statement or a false statement. This is a false statement. 0 is not greater than 3. 0 is not larger. We shade the region that does not include our test point. So we are now clear. Y less than or equal to -2. Again, a solid line. We have to first start by graphing the equality again of y equals -2. X coordinate, y coordinate. Now, -2 on the y-axis is down 2 units. It is right here. X is arbitrary, but y has to be a constant, -2. So we're going to have a solid line here through -2. And again, it's a solid horizontal line. If we notice, the origin is available. 0, 0 is available. That means x equals 0, and it means y is 0. So when I go back to my inequality, I don't have an x coordinate. I have just a y coordinate, which means 0 is less than or equal to -2. Again, this here is a false statement. 0 is actually greater than -2. So we're going to shade the region that does not include our test point, which is below this solid line. We're done. Number 29, 4x minus 2y is greater than 6. This is a strict inequality. So we're going to start by graphing the equality. We're going to do this by solving for y, putting this in slope-intercept form. We have -2y is -4x plus your 6. We divide by -2. Sorry, let's do this over. -2y, -4x plus my 6. We're now going to divide both sides by -2. Y equals -4x over -2 plus 6 over -2. Y equals positive 2x minus 3. When we do our arithmetic, our slope is 2, our y-intercept is -3. Slope is 2. Our y-intercept is -3. Let's go back and double check. That's true. Okay. Now remember, this is a dotted line, so let's get a graph. I have my x-axis, which is horizontal, my y-axis, which is vertical. My y-intercept is at the -3 value on the y-axis, so it's below 1, 2, and 3. It's in the negative portion. Let's highlight this point so we can see. Our y-intercept is at -3. We're going to use our slope value of 2 over 1, which means we have to rise 2. 1, 2, and run 1 to the right. This is the location of the second point. I get to draw now my dotted line through these 2 points. If I notice, my origin's available again. That means the test point of 0, 0, which is x is 0, y is 0, is available. The original question is number 29, 4x minus 2y is greater than 6. So when I plug in my x value and my y value, I get 4 times 0 minus 2 times 0 is greater than 6. Really, I get 0 is greater than 6. A false statement. I get to shade the region that does not include my test point. I am done. Number 31. 5x plus 3y is less than or equal to negative 15. Notice we have a less than or equal, which is going to give us a solid line. 5x plus 3y equals negative 15. We're going to have to solve for y. Negative 5x. Negative 5x. We get 3y is negative 5x minus 15. You can divide both sides by 3. Here's what we're going to end up with. 3's are going to cancel. Y equals, now the 3 is dividing both terms. So my equation becomes y equals negative 5/3 x minus 5. My slope value, my y-intercept. My slope here is negative 5/3, and then my y-intercept is a negative 5. Slope is negative 5/3. The y-intercept is negative 5. We need to graph. Okay. At negative 5, I have, first of all, the x-axis, your y-axis. We're going to have to plot down at negative 5. 1, 2, 3, 4, 5. So, the point on the y-intercept is down here at negative 5. We're going to have to go down 5 and to the right 3. Because my slope is negative, I'm going to use the negative value in my numerator. So I go down 5, an additional 5 points. 1, 2, 3, 4, 5. And then I go to the right. 1, 2, 3. Here's the location of the second point for the solid line. Now let's notice our test point, or the origin, is available for a test point. That means x is 0, and it means y is 0. Let's not forget our inequality. 5x plus 3y is less than or equal to negative 15. Plug in 0 for x. We get 5 times 0 plus 3 times 0 is less than or equal to negative 15, or 0 is less than or equal to negative 15. This here is a false statement. Shade everything to the left. You shade everything to the region that'll give you the true statement. and you're done. Number 33. 33, you now have a system. Y greater than negative x plus 4, and you have y less than x. We're going to look for points that satisfy both of these inequalities. Now notice they're both strict inequalities, which is going to mean we have dotted lines. But we're going to have to graph both of these. Y equals negative x plus 4 on the same Cartesian coordinate system. I'm going to change the color on this one. Let's make this one, I guess green. Let's see how green looks. Y equals x. So I'm going to call this maybe line 2, okay, and line 1. Let's be consistent. Let's try it this way. I'll give you less detail because by now you should be good with graphing these. And let's graph in blue line 1 and graph in green line 2. Now when I graph the blue line, and again it's going to be dotted, let's remember that it has a y-intercept at positive 4. So if we label our axes, x-axis, y-axis, at positive 4, we are 1, 2, 3, 4. We can now determine where 4 would be. Highlight it there. My slope value is negative 1. So that means I go down 1 and to the right 1. Again, down 1 to the right 1 from my y-intercept. We're going to have some dotted lines here. In blue, this is what the first inequality would look like, graphed. Let's be careful. Now, I'm going to determine what to shade here for the blue line here that's dotted. And again, the origin is available, 0, 0. So I'm going to test that. Origin means x is 0, y is 0. Now, for this inequality, I'm really testing whether 0 is greater than positive 4 by doing the arithmetic. I'll write it down better. 0 greater than positive 4. For our origin test point, now we know that this here is a false statement. So I'm going to shade the region that does not include this statement. Does not include this point. My test point that I used, again, the origin, was here. That gave me a false statement. That means the other region is going to give me true statements. That's the first inequality. Now in green, we're going to graph the second one. Y equals x is a line that goes through the origin, has a slope of 1. So if I put every detail here, we go through the origin with slope 1. Remember, this is plus 0. So you're going to get a line that looks like this. Don't forget, it has to be dotted. And we're going to have to be careful this time because of the fact that the origin is actually on, I should say our test point is on this dotted line. So In green, we have an upper left region and a lower right region. If I use a test point maybe down here, that's clearly not on the line. Let's determine where that is. This is x is 0, y is 1, 2, 3. 0, negative 3 here is going to be my test point for the green line. This is x is 0 and y is negative 3 for the second inequality. Now let's test this so we know. Is negative 3 smaller than 0? The answer is yes. So what we're going to do is we're going to shade, since this is a true statement, we're going to shade the region that contains that test point, which is the lower right region. This gets shaded. Now we're graphing a system of linear inequalities. We're looking for the region that is shaded twice. And if you take a closer look, the region that's shaded twice is this region over here. These points in this graph are shaded twice. So what we do here is we simply erase the points in blue, the points in green, and we keep the points that are in both blue and green. Keep in mind that you have a dotted boundary here for both lines. And if you like, you can erase some of these lines. This is your answer. $35. X plus y greater than 2, x less than negative 4. Now, again, in blue, we have to graph the equality, and we have to put this in y-intercept form. So if I subtract my x from both sides, notice the blue line here is going to be y equals negative x plus 2. Again, this line will be dotted because it's a strict inequality. My slope here is negative 1. This is for line 1. So we'll call it line 1 here. Line 2 now is simply x less than negative 4. Let's change its color. Line 2. X smaller than negative 4. We need to graph. Okay. In blue, my y-intercept, let's recall, we got some x-axis, we got a y-axis, so my y-intercept in blue is at positive 2 up here. I'm going to highlight that. My slope here is negative 1, which means I go down 1 to the right 1. Let's highlight this point here too. A dotted line through these 2 points. Okay. The origin is available as a test point, meaning 0, 0. If we plug these in, and we get 0 is greater than 2. That's a false statement. So this origin here is not the region, or we should say we're going to shade the region that gives us a true statement. The origin as a test point gives us a false statement. We shade the upper right region. Now, let's take a look at the line x is less than or equal to -4. We have this line here, so we know we have to graph the equality. And we'll put it in green. So let's find where this line is. It's at the x-coordinate is -4. 1, 2, 3, and 4 right there. If we highlight it in green so we can see it better, 1, 2, 3, 4, this is our location. That's where -4 would be, right here. Now, this is going to be a vertical line because we're always going through x being -4 for any y value. And again, it's dotted. So we draw a vertical line here through -4. And don't forget that our origin is available 0, 0. X is 0, y is 0. 0 less than -4. This is a false statement. That means we're going to shade the region that does not include this test point. That's the region that's strictly to the left. So if we take a closer look, the region that's shaded in both inequalities is this region here. This is going to be our final answer. All other things that we shaded can be erased. Even the portion of the lines can be erased. This is our final answer. $37. X minus y greater than 5. Actually, let's take a look. That's our second equation. Let's just be consistent. 2x plus y less than 4. X minus y greater than 5. These are strict inequalities, so we're going to have some dotted lines. We first start by graphing the equalities. Line 1. 2x plus y equals 4. And in green, well, let's actually solve this for y first. Subtract 2x. Y equals -2x plus 4. In green, line 2, we have x minus y equals 5. Solve this. We have -x minus y. Negative y is -x plus 5. Divide by -1 to both sides. See what we get. Y equals -x over -1 plus 5 over -1, or simply y equals x minus 5. These are the two lines that we're going to graph. So let's look at this line 1. Y equals negative 2x plus 4. Let's double check. And in green, y equals x minus 5. It's line 2. We need a graph. X-axis, y-axis. Our y-intercept is at positive 4. 1, 2, 1, 2, 3, 4. Here's the location at 4. We're going to use our slope of negative 2, which means we go down 2 and to the right 1. This is the location of our second point. Now again, we have strict inequalities. We'll have a dotted line here. Let's be a little more careful. It's a little bit difficult here. Okay, let's notice again here that our test point is available, and let's see what the original inequality is. Okay, your original inequality we'll write down here was 2x plus y being less than 4, and then we have x minus y greater than 5. Okay. Let's plug in and let's try the test point. Now, you may say why? Because it's available. It's right there. X is 0. Y is 0. If I do my arithmetic, I find 0 is smaller than 4. And that's a true statement. I get to shade the region that contains the test point, and that is the region to the left. Lower left, left, however you want to describe it, because this is our test point. This is what we get to shade with a dotted line. Now in green, let's try this out. We have the inequality x minus y greater than 5 in green. X minus y bigger than 5. We know we have to graph this in green as y equals x minus 5. So down here, 1, 2, 3, 4, 5, down here, I have my y-intercept, negative 5, and I use my slope here now of 1, so I have to go up 1 to the right 1 for the next test point. We'll highlight it. A dotted line through these 2 points. Once again, the origin is available right here of x is 0, y is 0. If I plug these in, we find that 0 is greater than 5. This is a false statement. So I have to shade the region that does not contain the test point. The region that does not contain the origin gets shaded. That is the region to the right of the green line. And again, I look for everything that is shaded in both regions. If I look carefully, this is what's shaded in both. this portion here. I then now get to erase everything else. This is what you should see as a final answer. (39), we have x plus 3y greater than or equal to 9, and then we have x minus 2y less than or equal to negative 6. Let's focus on the equations. X plus 3y equals 9. Now when we graph this, we are going to graph a solid line for both, but we're going to have to determine what each line is. So let's solve for y. Subtract x from both sides. You'll end up with 3y is negative x plus 9. Divide both sides by 3. We end up with y equals to negative 1/3 x plus 9/3. You get y equals negative 1/3 x plus 3. And here is what we're going to use. That's our line 1. In green, let's look at line 2. Line 2, x minus 2y is negative 6. Subtract x from both sides. You end up with negative 2y is negative x minus 6. We're going to divide both sides by negative 2. We end up with here y equals negative x minus 2 minus 6 over negative 2. Let's see what we get for line 2. Let's summarize though. What line 1 is negative 1/3 x plus 3. And we got line 2 is 1/2 x plus 3. Let's double check. That looks okay. We need a graph. We have x-axis, y-axis. Let's try graphing here the blue line. Remember, they're going to be solid. My y-intercept is at positive 3. So it's up 3 here, units. And then I'm going to use a slope of negative 1/3, which means I go down 1 and to the right 1, 2, 3 for the next point on my solid line. Let's draw these lines. Now notice the test point is available. That is x is 0, y is 0. So let's go back here. X is 0, y is 0. This means 0 is greater than or equal to 9. Well, that's a false statement. 0 is not bigger. So we shade the region to the right, the region that does not include our test point. The y-intercept is at 1, 2, 3 here, and our slope is at 1/2, which means we go up 1 to the right 2 for the location of our next point. These are the lines. It's solid, so let's draw a solid line through these 2 points. Our ruler is running out here. Okay, here we go. Let's find the test point at the origin. It's available. T is 0, or the x is 0, y is 0 here for my test point. Let's go back now. 0, 0, and I get 0 minus, or let's just simply say that 0 will be less than or equal to -6. 0 is not smaller. This is another false statement. So I shade the region that does not include the test point, and that is the region here to the upper left. So if I take a look closely here, I need to find the regions that are shaded in both. Top. We're going to erase now everything else. It looks like we lost too much information. We lost our lines. So let's go back here. Let's try the green line, I guess. Okay. Try the blue line now. Something like this. This is what you should see here as what's shaded in both. Number 41. X greater than or equal to 5 for 41. Y less than or equal to 4. Again, if you notice, solid lines. They are greater than or equal to sign and less than or equal to. So we're going to actually look at L1 being X equals 5. And then we'll look at L2 being Y equals 5. Vertical lines, horizontal lines. Need a graph. Let's see. X-axis, Y-axis. In blue, X is 5. 1, 2, 3, 4, 5. Right here. We're going to draw R. Looks like it's a solid line. Vertical line through 5. Here's our line. Y is 5. Oh, excuse me. Y is 4. That's 1, 2, 3, 4 here. A nice horizontal line for Y is 4. Okay. Okay. In blue, notice in both of these problems here, the origin is available as a test point. That's my favorite test point. So in blue, I know X is 0 and Y is 0. So that means for the first blue equation here, 0 is greater than or equal to 5. That's a false statement. So I get to shade the region to the right, or I should say the region here that does not include our test point, the region for the blue line that does not include the origin. In green, again, my test point of the origin is available. That means X is 0 and Y is 0. So if I plug in 0 for Y now, I get the statement that 0 is less than or equal to 4. A true statement. So I get to shade the region that includes the test point. That's the region below the green line. So when I shade, we're going to try to look for here the overlap. Regions that are shaded in both. Then we get to keep the points that are in both shaded regions. If we look closely, they are right here. They are everything below this green line and to the right of the blue line. This is what we're looking for. We get to erase things that are shaded once. And keep things that are shaded twice. Now, we get to even get rid of these lines here, but let's be careful. Because what we're communicating to people is everything that's shaded here is actually a solution. So let's be very careful. This corner here is your solution. Y greater than or equal to 2x, y less than or equal to x minus 3. We're going to graph both of these equalities. Y greater than, I just said equality. Y equals 2x in blue, and in green, we'll graph y equals x minus 3. They're both going to be solid lines. So in blue, let's take a look. Y-intercept's at the origin. Here, slope is 2. We go up 1, 2, and then to the right 1. Let's highlight these points in blue. Y-intercept, the next point. Get to draw these solid lines. Something like this. And then in green, let's be careful here. In green, we have a y-intercept at -3. So it's 1, 2, 3 down here. And then I get to do my slope here of 1. So I go up 1 to the right 1. Okay. Let's draw this green line. Let's notate where this point is. Okay. Now for the blue. We're going to determine the region we shade for blue. If we want, let's be a little more careful here. Yeah. Okay. For the blue line, we need a test point. Now, this isn't going to be so easily done like the prior problems because it looks like the origin's not available. So let's pick a point clearly here outside for blue, the origin. Let's see what point that is. X is 0. Y is 1, 2, 3, and 4. So right here, X is 0. Y is 4. So for blue, X is 0. Y is 4. All right, 0, 4, and let's see, we say 4 is greater than or equal to 2 times 0, which is 0, and that's a true statement. So in blue, we get to shade the region that contains our test point. Let's be careful here. This could be pretty sneaky or pretty tricky, sorry. Here's my region. It contains the test point. Okay. Okay. Now we're lucky for green because of the fact that the origin is available. 0, 0 is available in green. So let's put 0 and 0, and let's see. 0 less than or equal to 0 minus 3 is negative 3. Now, this here is a false statement because of the fact that 0 is simply not smaller than negative 3. So we shade the region that does not contain the test point, and that's the region to the right of this line. Now let's be really specific here. If we notice the region that's shaded twice, it's this region here in this corner. We have solid lines, so what we get to do is really emphasize where that line would be. Here, here for a boundary, and again we're shading that region in black, so we get to erase everything else. This is gone. This green is gone. Even these lines are gone because of the fact that, except for the black line, this is our shaded region that satisfies both inequalities. We are done.